So 8-7, we are solving logarithmic equations. So this week is definitely about solving and making sure we can solve for the variables. So the first things first is I really do want you to try out this bell work. You're going to use a calculator to evaluate the following. So go ahead and take a minute and get the answers to the next 6. Go ahead and pause your video if you need to. As a quick reminder, we do have the log button here and the ln button here. So when you are putting in log, all you have to do is press 7 and then enter, and you should see a very nice positive number of 0.845. Okay, so make sure you go ahead and do that. I would like you to practice. This is great practice for you and your calculator. But just so we can get through, I'm going to go for it. So our first one is actually a 0.845. So that's positive. That's awesome. When you plug in log of 0, something happened, right? It said error. And when you plugged in -2, it should also have said error. Might be something going on here. Again, now we're moving on to ln. ln is right below that log button, right here. So when you plug in ln, and then you're going to plug in 5, you press enter, and you're going to see that it is a 1.609. So again, we're getting an answer. That's awesome. I'm going to put 1.61. As you continue, as you plug in -1 and 0, you're going to hopefully get error. So there might be something happening here. Based off of these answers, what type of numbers do you think you can take log of? You should kind of see. So it should be positive integers, so not negatives or zeros. They don't work, okay? So as you can see, we have to have positive numbers inside of a log and natural log. You cannot do 0 or negatives. So that's a good hint of what is to come. So our first order of business is again our essential question of the day. What are the steps used to solve logarithmic equations? Well, there's a process. In that process, we have 5 steps. First step is we're going to use log properties to simplify to 1 log. That's going to isolate the log by itself. We're going to rewrite it in exponential form. We're then going to solve for our variable. And last but not least, we're going to check for those extraneous solutions. So those are coming back into play from the beginning of last year. Last year and the beginning of this semester, we had extraneous solutions. So they are coming back. Make sure you remember to check these. That is important. Now that we have the process, let's get into solving our problems. So our first example, we have 2 log 2 of x plus 1. This 2 of x is alone. It does not have that plus 1. We would know it was together if there was parentheses. Please pay attention to that one. So our first step is to simplify. Well, we need to simplify to 1 log. There is an integer here. So what I'm going to do is I'm going to make it become an exponent. This allows this to become log 2 of x. The whole thing is going to be squared, okay? So just because this is 2x, this is not 2x squared, it's the whole thing, 2x to the squared. Still plus 1 equal to 3. Well, we've simplified the log. We now need to solve for the log and isolate it. So we're going to subtract 1. We're going to get log parentheses 2x squared equal to 2. Now that we've done that, we now can see that we can transform it to the exponential form. If there's nothing there, our base is 10. So this becomes 10 to the squared equal to parentheses 2x squared. At any time you could have simplified that, I'm just writing it out. So now it's just an equation. Can you solve for x? Well, 10 squared is 100. It equals now 2 squared, 4, and then x squared. Now I just need to get x all by itself. I'm going to divide by 4 to get 25 equal to x squared. To get rid of a squared, we take the square root, and we know x has to equal plus or minus 5. So we have our answers for x. Next step is we need to check, okay? So to check, biggest indicator is can the x go into the logarithm? So to the original logarithm. So we had log of 2 of x with a bunch of stuff with it. But to check it, all you have to understand is the inside of my log positive? If it's positive, you're good. If it's negative or 0, you cannot take the log of it. So that's how we're checking extraneous solutions. So if we check 5, we're going to get log 2 times 5, which is log to the 10th. So we're good. If we check negative 5, we're going to get log 2 times negative 5, which is log to the negative 10th. Therefore, we can see we can't do that because there is a negative inside of the log. So that just means our official answer is x equals 5. Okay? It's a terrible marker. I will change it. It is x equals 5. So we know it can't be the negative 5 because when we plug it back in, the logarithm inside becomes negative. We cannot have that happen. If you feel confident about after our first example, please go ahead and start number 2. We are going to be manipulating it, then isolating, and doing exactly what we just did. All right. So for number 2, I have log of 3x plus 2 plus log of 3 2x minus 3. So this is where our properties come in. This plus says I need to multiply these, make it one log. So we're going to get log of 3 x plus 2 times 2x minus 3, still all equal to 2. Well, the log is isolated, so we're good to go. I can now manipulate this into exponential form. I have a base 3, which will be squared. It's going to equal x plus 2 times 2x minus 3. All right, so all you have to do now is simplify and then start solving for x. We have 3 squared, which is 9, equal to, we're going to get x times 2x, 2x squared, x times negative 3, 2 times 2x, and 2 times negative 3. We should now solve. So we get simplify, combine like terms, that word. 2x squared plus x minus 6. We're starting to see where this is going. So we're going to minus 9, because what we need to do is set the equation equal to 0. That's something you're used to? It should be. We are going to be doing the AC method. I know all of you love it, but we're going for it. So we have 2x squared plus x minus 15. Our AC is negative 30, and we need factors to get to 1. Well, I'm going to give you a hint. 6 and negative 5. That should get you to 1. So that means we're going to set this 0 equal to 2x squared plus 6x minus 5x minus 15. Because remember, we are breaking apart the b with the 2 factors. And then we're going to group everything. We're seeing here we can take out a 2x, which becomes an x plus 3. Take out a negative 5, which becomes an x plus 3. Rewrite, we get x plus 3 times 2x minus 5, all equal to 0. Now I solve for x. Set x plus 3 equal to 0, subtract 3 to both sides, x equals negative 3. Do 2x minus 5 equal to 0, add 5 to both sides, and then divide by 2. So we have an x of negative 3 and an x of 5 halves. So we need to check. logically, you should be able to do that in your head and throw in your x's to your logs. So just as a quick reminder, if x equals -3, I plug it into x plus 2. -3 plus 2 is a -1. It does not work. So this cannot work. What about x equals 5 halves? I choke. So 5 halves, we do that plus 2. There's no negative there. 5 halves plus 2 is 9 halves. And if we do it in 2x minus 3, 2 times 5 half is 5. 5 minus 3 is a positive 2. So it works. So our answer has to be 5 halves. So we have to check, because if you would have plugged in -3, you would have gotten an error, and therefore it would not have worked. Okay, so go ahead and take a break and see if you can figure out the next two. If not, please join me in the next video.